Dear students, we have discussed the concept of MRS, marginal rate of substitution, in the previous class. Now we discuss diminishing marginal rate of substitution. And it is also a case of strict convexity of indifference curves. Strict convexity of indifference curves. Now, diminishing marginal rate of substitution exists when MRS xy approaches to 0 as x increases. MRS xy approaches to 0 as x increases. xy as you can see in this graph, as x increases, slope of the indifference curve tends towards 0, become less negative, or we will say that the slope of the indifference curve increases. Slope increases, say from minus 4 to minus 3 to minus 1 to etc. 0. And as MRS is the negative of the slope, MRS on the other hand decreases as x increases. Slope increases, MRS decreases. MRS decreases as the quantity of x increases and the quantity of y decreases. For low values of x, as you can see, consumer is willing to give up a large quantity of y. For example, here, for getting 1 unit of x, the consumer is willing to give up a units of y. So at point A, our consumer is willing to give up a units of y for getting 1 unit of x. At point B, our consumer is willing to give up only b units of y for getting 1 unit of x. So his willingness to substitute y for x decreases as x increases, and note that a is greater than b. So for example, a may be 4, b may be 1. He is willing to give up 4 units of y for 1 more unit of x. Here he is willing to give up only 1 unit of y for 1 unit of x. So the marginal rate of substitution, MRS, decreases as we move from left to right along an indifference curve, as the quantity of x increases. An alternative way of stating the principle of diminishing marginal rate of substitution is use the mathematical notion of a convex set. We use the notion of a convex set to denote diminishing marginal rate of substitution. A set of points is said to be convex. A set of points is said to be convex if any 2 points within the set, can be joined by a straight line that is contained completely in the set. Let me repeat, a set of points is said to be convex if any two points within the set can be joined by a straight line and the straight line is contained completely in the set. The assumption of diminishing marginal rate of substitution is equivalent to the assumption that all combinations of x and y that are preferred or indifferent to a particular combination form a convex set. Consider a combination x star y star and consider all the combinations of x and y that are preferred to or indifferent to the combination x star y star. And if all these combinations which are preferred or indifferent to x star y star constitute a convex set, it is equivalent to diminishing MRS. So diminishing MRS is equivalent to the statement that all combinations of x and y that are preferred or indifferent to a particular combination form a convex set. As an example, you consider this graph y, x, u, u1. Now consider a combination y star, x star. This combination, we know that all the combinations in the shaded area are preferred or indifferent to y star and x star. And you consider two such combinations, combination A and combination B. So this is y1, x1, this is y2, x2. And suppose that you join this with a straight line and the straight line is completely within this set. So it is a convex set. So the combination is x star y star and all the combinations which are preferred to or indifferent to the combination x star y star is in the set denoted by the shaded area. So this is a convex set and it is equivalent to the statement of diminishing MRS. So, and remember this, if you take any two combinations A, B or any other combination, and if you join together these combinations with a straight line, this straight line is also contained in this set, in this shaded area. So in the context of indifference curves, diminishing marginal rate of substitution is equivalent to the assumption that all the combinations of x and y that are preferred to or indifferent to a particular combination y star x star form a convex set. So in the figure, the shaded area represents all the combinations which are preferred to or indifferent to x star y star. And if you take any two combinations A and B, and suppose that you join this with a straight line, the straight line is also in the shaded area, so contained in the shaded area. So this is the mathematical equivalent of diminishing MRS. Now suppose that you have a different situation. The situation is like this. Like this. Now you consider a combination y star x star. Now you consider and this shaded area represents all the combinations which are preferred to or indifferent to the combination represented by y star x star. And consider two combinations A and B. If we join together A and B with a straight line, then it passes through the unshaded area also. So, the indifference curve through x star y star does not obey the assumption of diminishing MRS, because the set of points preferred to or indifferent to x star y star is not a convex set. Diminishing MRS require that all the combinations which are preferred to or indifferent to that particular combination is form a convex set. Here all the combinations preferred to or indifferent to the combination x star y star is not a convex set, because if you join together 2 points in the set with a straight line, it will not lie, the straight line will not lie completely in the set. That is why it will not satisfy the assumption of diminishing MRS. And by using the notion of convexity, we can say that there is an alternative interpretation to convexity. The alternative interpretation is that individual consumer always prefer some balance in consumption. The individual always prefers some balance in consumption. Let us see what is meant by balance in consumption. Suppose that we have a situation like this: y1 x1, y2 x2 y2, x2 y2, and you consider the average. This is point A, point B, this is point C. Average. This average is x1 plus x2 by 2. This is y1 plus y2 by 2. Now, what is meant by balance in consumption? Suppose that the consumer is indifferent between x1 y1 and x2 y2, and you consider an average of these two bundles A and B. The average is obtained by taking adding and dividing by 2, and you can see that this C is not on the indifference curve. It is on a higher indifference curve using the assumption of non-satiation. That means C is preferred to A and B. So, in an intuitive sense, the implication of diminishing marginal rate of substitution is that well-balanced diversified bundles are preferred to bundles heavily weighted towards one commodity. Well-balanced diversified bundles are preferred to bundles heavily weighted towards one commodity. That is, household prefers averages to extremes. So, the assumption of strict convexity is equivalent to the assumption of diminishing MRS, and it rules out the possibility of indifference curve having straight line segments. Strict convexity means diminishing MRS. An alternative interpretation is averages are preferred to extremes, and it rules out the possibility of straight line segments to the indifference curve. Now this is the average of 2. This can be generalized like this. Any proportional combination of two different bundles preferred to initial bundle as a more balanced. If you take a proportional combination of two bundles, again it is preferred to the initial bundles because the proportional combination is more balanced compared to the initial bundle. So diminishing MRS is equivalent to strict convexity. Its intuitive explanation is averages are preferred to extremes. Now consider an indifference curve which is not convex. The shape is like this. The shape is now, if the indifference curve is concave, now if you can see that this is one combination y1, x1, another combination y2, x2, and this is x1 plus x2 by 2, and this is y1 plus y2 by 2. Now this is one indifference curve u1, this is second one u2. Now this is a case of increasing marginal rate of substitution, and as the consumption of x increases, MRS increases, and in this case extremes are preferred to averages. For example, the average is represented by this point C on the indifference curve U1. But points A and B are extremes on indifference curve U2. And as you can see, extremes are preferred to averages now. And this is a violation of what is known as diminishing marginal rate of substitution, convexity, balance in consumption, etc. In this case, what happens is extremes are preferred to averages. Now the question is whether you will encounter such situations in the real world. There are. As an example, alcohol and driving. Alcohol and driving. You prefer to drink or you prefer to drive, not alcohol and driving. Similarly, in an examination, all grades A than combination of A and B. All A grades than combinations A and B. So there are examples, there are situations in which extremes are preferred to averages, but such cases are limited. In most cases, the household diversify, prefer averages to extremes as it increases utility. So this is diminishing marginal rate of substitution. It ensures strict convexity of indifference curves. Its economic interpretation is averages are preferred to extremes. In most cases, we stick on to this. There are extreme cases in which this assumption will be violated.